Hi, PerspectaWeather.com meteorologist Paul Dorian here on June 25th. Well, we're approaching the end of the month of June, the beginning of July. It looks like a heat wave is coming to the Mid-Atlantic region that begins at the end of this week. It continues well into the first week of July. But I want to take a long look ahead to some signs for the upcoming winter season. Yes, summer solstice has just passed, but the days will grow shorter and shorter from here on out until the winter season gets underway. And there are some interesting signs that point to the possibility of a cold and snowy winter in the Mid-Atlantic region. We'll focus in on that over the next several minutes. Of course, this is all in the speculation phase, but nonetheless, there are some factors that we will monitor closely over the next several months. And there are some early signs here for a potential cold and snowy winter in the Mid-Atlantic region. First of all, and foremost, I'd like to take a look at oceanic temperature anomalies, at least those that are predicted for the fall and the winter season. That's the first step whenever making a long-range outlook, is to try to develop some kind of a consensus on what kind of sea surface temperature anomalies there will be, especially in the Pacific Ocean. That is by far the biggest of all the oceans on the planet and has a critical plays a critical role in all weather and climate, and is the first place we want to look for a potential outlook for the upcoming winter season, which of course is still several months away. First of all, this is a bunch of computer forecast models, dynamical and statistical models in the forecast of sea surface temperature anomalies in the tropical part of the Pacific Ocean. This is the area west of South America, right along the equator in the heart of the Pacific Ocean. And it looks like most models, if not all models, have a prediction of an El Nino to form by the latter part of 2018. Certainly by the fall season, there should be, according to these models, at least a weak El Nino getting underway. Now, right now, we're kind of in a neutral zone, coming off a La Nina condition in the tropical Pacific. La Nina, colder than normal temperatures. El Nino, warmer than normal temperatures. And again, it looks like we'll cross that neutral threshold, which is shown right here by this thick black line going across, into El Nino territory. And this particular map has rolling 3-month periods, and we go all the way out to this time frame right here. This is December, January, and February, the last month of 2018, the first couple of 2019. Again, most models predict a weak to moderate El Nino in the tropical part of the Pacific Ocean. That is one important factor. Not only is the strength important, but the exact location in the tropical Pacific is of importance as well in determining temperature patterns here in the Mid-Atlantic region. We'll kind of focus in on the location of this potential El Nino over the next couple of minutes. Well, let's begin here in terms of trying to determine the location of a potential El Nino late this year and into early 2019, right through the winter season, the upcoming winter season. Two areas I want to point out here. First of all, this is a forecast map from NOAA's climate model called the CFS version 2. And what we're looking at is a sea surface temperature anomaly forecast map for the December, January, and February, the upcoming winter season. Of course, it's several months away. Certainly nothing set in stone here, but this is an early sign that the El Nino that very well is likely to form later this year going into the winter season, the early part of next year, will be kind of focused or concentrated in the central part of the Pacific Ocean, the equatorial Pacific. This line right here, this dashed black line here, represents the 0-degree latitude, the equator. And again, the CFS model is predicting El Nino basically west of South America, which is located right here, the west coast of South America, but kind of focused on the central part of the Pacific Ocean. And that is crucial because, first of all, if there is a strong El Nino in the eastern part of the Pacific Ocean in the wintertime, that tends to push warm air right into the eastern third of the nation. However, if there is an El Nino in the central part of the Pacific Ocean, focusing right in this region, that is really what this model is hinting at. That allows for the possibility of cold air masses to drop south and east into the northeastern part of the country. So a central base versus an eastern base El Nino is critical, and in this case, signs are pointing to a central-based El Nino for the upcoming winter season. That allows for some cold air outbreaks into the northeast U.S., but a strong El Nino, for example, in the eastern part of the Pacific Ocean often ends up producing warm winters in the mid-Atlantic region. 97, 98 is an example, 72, 73, both strong El Nino winters, and they were eastern-based El Ninos. Also, notice up here in the Gulf of Alaska, just south of the Alaskan southern border, southern coastline, the CFS model is predicting warmer than normal conditions in that part of the Pacific, basically the northern Pacific or northeastern Pacific. That is pretty reminiscent of what happened kind of the middle part of this decade in the winter, for example, of 14, 15. And what that tends to do is allows for the formation of upper level region right in this region right here, high pressure along the west coast of Canada and even the west coast of the U.S. And that also is a signal for the possibility of cold air outbreaks into the northeastern U.S. with high pressure ridging right here. Tend to have a dip in the jet stream right in this region right here, and that allows again for cold air to penetrate into the northeastern U.S., the mid-Atlantic region from places like Canada, Greenland, even across the North Pole in Siberia. So two interesting factors here in NOAA's climate model for the upcoming winter season. Basically the prediction of a central-based El Nino, and probably, in the weak to moderate strength category, and also a warmer than normal blob of water in the Gulf of Alaska. Crucial factors to consider for the upcoming winter season. Well, let's take a look at another computer forecast model with respect to sea surface temperature anomalies for the upcoming winter season, December, January, and February. This is from the Japanese Meteorological Agency. The model is known as the JAMSTEC. Has a pretty good record. I've been following this, using this over the last several years, and a pretty good record. And the interesting thing is how well correlated it is, how well supportive it is of NOAA's CFS V2 model. Notice a focus of El Nino shown on this particular map in the reds. Again, focused in the central part of the equatorial Pacific. This is the equator right in here, and not really, it is warmer than normal in the eastern tropical Pacific, but basically focused out in the center part of the Pacific, just like NOAA's CFS V2. Also tucked into the Alaskan coastline here, the Gulf of Alaska, a warmer than normal blob of water predicted by this particular model, in this case from the Japan Meteorological Agency. So again, both of these point to the possibility of cold air outbreaks into the northeast U.S. And by the way, the El Nino tends to, at least in the central part of the Pacific, tends to increase the chance for coastal storms along the east coast of the U.S. Basically, it activates the southern part of the jet stream, the southern branch of the jet stream. It adds moisture as well into the southern branch of the jet stream, and ultimately that increases chances for coastal storms in the eastern U.S. whenever you have that centrally based El Nino, and that, of course, is the best path for a storm to allow for the possibility of snow in the big cities of D.C., Philadelphia, New York City. So again, centrally based El Nino, warm blob in the Gulf of Alaska, supported here by two useful models here, NOAA's CFS and a Japanese model known as the JAMSTEC. Well, let's take a look at another factor here. One thing I always like to look at is solar activity. And as we have highlighted many times here at PerspectaWeather.com, we are currently in a historically weak solar cycle, number 24. It's one of the weakest solar cycles, really the weakest we've had in terms of sunspots in more than a century. The last solar minimum took place around 2008, 2009, and that too was a historic quiet period, one of the quietest periods in terms of solar activity in the last 100 years or so. And we are rapidly approaching the next solar minimum. Looks like by next year, for example, we should be right in the heart of the next solar minimum, coming out of a historically weak solar cycle 24. Why is that important? Well, low solar activity tends to be pretty well correlated with what I like to refer to as high latitude blocking events, where high pressure, higher than normal pressure, situated over places like Greenland or Iceland or northern Canada, and that typically allows for the penetration of cold air masses into the northeast U.S., into the mid-Atlantic region. And here we stand right now. Little doubt that there will be low solar activity right through the upcoming winter season. There's always some doubt in terms of the forecast of an El Nino. In fact, a year ago, some of these same computer forecast models that we looked at a few moments ago predicted El Nino would develop by the summer of 2017. And that really failed to materialize, and that caused a big shift in the tropical season for 2017 in the Atlantic Basin, when it looked like El Nino was not going to form and neutral to La Nina conditions would continue. That all of a sudden raised the possibility of more active tropical weather, and indeed it turned into a very active tropical season. So those forecasts for El Nino are always in question 3 to 6 months ahead of time, but I feel very, very certain that low solar activity is almost a guarantee, because we are already in a historically weak solar cycle, and we're headed rapidly into the solar minimum. This is where we stand right now in terms of this phase of solar cycle 24 right here. We are coming out of that particular solar cycle into the next solar minimum phase. Well, again, why is that important, low solar activity during a winter season? Solar activity generally has a long-term impact on weather and climate, but there are also some well-correlated evidence that it has a kind of a short-term impact. If we have low solar winter seasons, that is well correlated with high latitude blocking. This particular plot right here from NOAA shows the 500 millibar height anomalies in low solar activity years, basically solar minimum years. All of these years right here in this list right here, 1953, 54, 55, for example, all the way up to 2006, 2007, 2008, basically occurred during solar minimum phases. And again, we're headed rapidly into that one. And look at the 500 millibar height anomaly for this. Really shows up clearly here with above normal heights over places like Greenland and Iceland. This is, again, what I refer to normally as high latitude blocking. Higher pressure than normal in this part of the northern hemisphere tends to allow for the penetration of cold air masses during the winter season into the northeast U.S., into the mid-Atlantic region. So again, low solar activity, which is almost a certainty for the upcoming winter season, allows for the possibility of numerous cold air outbreaks in high latitude blocking scenarios during the upcoming winter season. Well, one last factor I'd like to talk about. Anyone who has viewed my videos over the past several years, especially in terms of the winter outlook, know that I always monitor the snow cover in the northern hemisphere, especially, for example, around Siberia during the autumn season. October seems to be kind of an important time period to track the developing snow cover, snowpack in cold air source regions. Well, another cold air source region for the mid-Atlantic region, northeast U.S., is Greenland. And so the snow and ice extent Greenland is also important, as is Siberia, for example. And right now, we're well above normal. This arrow right here points to where we stand right now. Basically, this gray line right here represents the mean over the 1981-2010 time period in terms of snow and ice extent on Greenland. We're well above that right now. And that has basically been the pattern over the last several months. So that's kind of an important factor. Anytime you have above normal snowpack in a cold air source region like Greenland or Siberia or northern Canada, for example, that again bodes well for the development of colder than normal air masses that can penetrate into the northeastern U.S. during an upcoming winter seasons. So this particular signal right here from the snow and ice pack currently on Greenland is a bullish sign for potential cold weather during the upcoming winter season. Of course, as the fall approaches, we'll monitor what's going on in Siberia. So again, we've taken a look at a few different signs that point to the potential, and this is all in the speculation phase, for cold and snowy weather in the mid-Atlantic region. First of all, the forecast of an El Nino, probably a weak to moderate El Nino based in the center part of the tropical Pacific during the upcoming winter season. That presents the possibility of cold and snowy winter in the Northeast, maybe some coastal storm activity as well. Also, the prediction by a couple different models here of a warm blob of water in the Gulf of Alaska. That tends to favor high pressure ridging along the west coast of the U.S. and Canada, which in turn allows for the penetration of cold air outbreaks into the Northeast U.S. Low solar activity seems to be a guarantee for the upcoming winter season. That is often correlated with high latitude blocking patterns, which tend to favor cold air outbreaks in the Northeast U.S. And finally, the snowpack, the ice pack on Greenland right now above normal. We'll of course monitor that over the next several months, as well as what happens in the fall over Siberia. So just a long look ahead here, just past the summer solstice, but it won't be too long before we get into the fall and towards the upcoming winter season of 2018-19. That's it for now. For PerspectaWeather.com, I'm meteorologist Paul Dorian.